Okay, this is review for our junior high math chapter 9 test that we will be having Monday, March the 4th. Today I went over briefly in class with what's going to be on there. To recap, you'll have chapter 9.1. In this section we talk about square roots. You'll have approximately 10 questions from that, and this to me would be somewhat of a score booster on basic questions such as what is the square root of 196, in which you would give me 14. I would know from this a very important question I've seen on an ACT before that says how many possible answers are there to a square root? The answer is actually 2, because in the previous problem the square root of 196 is 14. It actually can be positive or negative 14. Negative 14 times negative 14 equals 196. Positive 14 times positive 14 equals 196. So knowing that would be a very good thought of how many possible answers are there to a square root. All right, moving on chapter 9.3, we talk about the Pythagorean theorem. Now, what I've seen when most students struggle with this is, well, knowing the formula, and what if they don't give you the correct angle letters or name the angles A, B, C. Pythagorean theorem states that A squared plus B squared equals C squared, but more importantly, know that it's the leg squared plus the leg squared is equal to the square of the hypotenuse. Now, hypotenuse is always going to be your longest side of your triangle. It's always opposite the right angle, so I always say the best thing to do, well, that's a terrible triangle. The best thing to do starting off is to find first where your hypotenuse is. And it's very easy to find. It's always directly across from the right angle. So this is my hypotenuse. It's my longest side. So there, if let's call the hypotenuse x. Let's say this is 7 and this is 9. So in this triangle right here, we are looking for the hypotenuse. Now, don't get too caught up in, well, is this one A or is this one B? That's not as important as knowing that it's the two legs. Take the hypotenuse and put it by itself on a side, and then just simply say 7 squared plus 9 squared equals x squared, which is your hypotenuse. So you would have 49 plus 81 equals x squared, and this would give you 130. Is x squared. So when we take the square root, get a calculator, you can easily find that right above the square button of 130, close parentheses. It's 11.4. So therefore I know that my hypotenuse is 11.4. Now at the end of this problem, the main thing to remember is this step right here. Because whether you're looking for the hypotenuse or a side, you will always take the square root lastly. All right, and the last big section of the test probably is the most important, or that you may struggle the most with. This is section 9.6, and it is your trig, or trigonometric ratios. Okay. Now, 9.5 talks about special right triangles such as a 45, 45, 90, and 30, 60, 90. And in class, I've kind of gone over with that. Those are more along the lines of a shortcut, being able to distinguish the differences in the triangle and the way that the ratio is set up saves you some time. But this works for any right triangle, whether in 8th grade math, 7th grade math, we're learning strictly right now to find the sides. So we're not going to worry too much about how to find the angles, but to find side lengths. We do that with sine, cosine, and tangent. Okay? The sine of an angle is equal to the ratio of the opposite side, or opposite leg, we'll call it, over the hypotenuse. The cosine of an angle is equal to the adjacent leg divided by the hypotenuse. And the tangent is equal to the opposite side, or opposite leg, divided by the adjacent leg. The way that I remember this is so, ka, toa. And probably the hardest part of a triangle is when we have a right triangle. And there's our right angle. Let's say, for instance, we call this one 37 degrees. Let's say we're looking for x, and we're going to give you 12. So here's an example of what you might see on a test that's talking about, using a trigonometric value. How would you find the measure of x? Well, first thing I always say to do is I go through it methodically, step by step every time. I circle the angle that I am given. Now, of course, yes, we're given this 90-degree angle, but you never use that much in trigonometry except to help you locate the hypotenuse. So I circle the angle that I'm given. My next step is I find my hypotenuse, which is x, and I put an h by it for hypotenuse. Then from the 37-degree angle, I come straight down or across, and I find 12, which is my opposite. So I put an O there. So there's the hypotenuse side, the opposite side. So the only thing that I'm left with now is the adjacent side. Now, I always come over here and I write out so, ka, toa. And now looking at that, I go, okay, what did they give me? What must I use on this? Obviously, we're going to use the 37-degree angle. They give me 12, which is opposite, so I underline the O. And then I'm looking for h, which is my hypotenuse, so I underline the h. Now, the adjacent side, they don't give me, nor am I looking for it. So really, any of the SOHCAHTOA, anything with the adjacent side I don't use. Well, looking at this, the one that I'm going to use is sine. Sine is opposite over hypotenuse. And I am given the opposite, and I'm looking for the h. So it's the one that I've underlined two of my letters with. Then I simply set it up, and I go sine of a 37-degree angle, always put it over 1, is equal to opposite, which is 12, over x. Now, if x is in the denominator, that means that I'm going to divide. So first I'll cross multiply. 12 is equal to x times sine 37. Now, the sine 37, I'm multiplying times x. So the opposite of that is to divide this side by sine 37. And I must also do this side by sine 37. Therefore, it gives me that x is equal to, and I'll cut my light on so maybe you can see a little better and zoom in. And I just simply say 12 divided by sine of a 37-degree angle, close parentheses, enter 19.9. So 19.9 is my answer to that. Now, if I had said, that was the only one I could use on that, but let's say, for instance, we were looking for, one more example would be a triangle, and they give us that. They tell us that this is 13, this is 41, and we're looking for x over here. Now we have something a little bit different. I want to show you this one because the function will actually set up a little different. Still start off, so I'm going to block out all of this, whole new problem here. They give me 41 degrees, so I'm going to circle that angle. Now I'm going to go straight across from my right. There's my hypotenuse, straight across from that. So x is my opposite, and this is my adjacent. So once again, it's going to line up. If you know so, ka, toa. Opposite is what I'm looking for, and I'm given my hypotenuse. So this will be sine also. It's going to work out a little bit differently. I'll say sine 41 over 1 equals opposite, which is x, over my hypotenuse 13. Notice in this one, the x is in the numerator. And in this ratio, x was in the denominator. Think, denominator equals divide. Numerator, all we're going to do is cross multiply. So we're going to say x equals 13 times the sine of a 41-degree angle. So I'm going to take my calculator, and where you can see it, 13 times sine 41, close parentheses, 8.5, if I'm rounding to the 10th spot. So x is equal to 8.5. So the difference is, in this one, x is in the numerator, I just multiply. This one, x is in the denominator, denominator equals divide, I know that I have to divide. So if you'll memorize those trig formulas, or more importantly, just know SOHCAHTOA, you will do fine. This test will consist of 30 questions on Monday, March the 4th. And the question that I would know possibly for a bonus is, how many possible answers are there to a square root problem? And the answer is 2. Good luck, and hope this video helps.